Good afternoon, everyone. After 3 days of diagramming, we're now going to start talking about matrices. And we will tie the two things together in the next few days. But today is basically going to be introducing what they are and just talking about basic operations and things you can do with them. So what is a matrix? So essentially, a matrix is kind of a fancy mathematical way to say a table of numbers. Okay. So matrix is a rectangular array of numbers set out into rows and columns, so kind of like a spreadsheet. In general, an m by n matrix has m rows and n columns. So this is basically your dimensions, right? A 3 by 4 matrix has 3 rows and 4 columns. Okay, we can use capital letters to note the whole thing. So if I have a matrix and want to talk about it, I can just reference it with a single letter. That's a capital. Okay, and we use lowercase letters with subscripts, okay, to note an entry in the matrix. So something like this, A, 2, 3, means that within matrix A, I'm talking about the item in the second row and the third column. Okay, so in general, it kind of looks something like this. And let's move that over here. Okay, it's just some kind of a table, right? So the rows are this way, right? This is going to be like my first row. Okay. And the columns are running the other way, okay, vertically. And actually, to highlight this, when I'm talking about 2, 3, right, that means if I go into row 2 and column, that's row 2, and column 3. So that would be this element right here, row 2, column 3. Okay, so that's what that means. Okay, so what can I use this for? Well, the first thing is that just pretty much, again, any kind of a table of data can be turned into a matrix. Okay? So for example, don't write down this table below right away, okay? But these are the Memorial Cup standings from last year. Okay, the most recent Memorial Cup has not started yet. Okay, but if I was going to take this and turn it into a matrix, all I really have to do, right, is say, okay, there's my boundary lines, and I get rid of some of these details if I feel that I can. Okay, so that's all it really takes to turn a table into a matrix, is just record the numbers and leave out the details. Okay, again, from the top here, places you might want to do that. You can do sports standings, okay, for teachers, marks, okay, for business, sales figures. Okay, we're also going to see how you can connect these to network diagrams and tree diagrams and probability and a whole bunch of other things. Okay, but that's the basic idea. Is if you strip away some of those details and just have a table of numbers, that's what a matrix is. Okay, so hopefully everyone's have time to get down what they need to there, and we'll go on to the next thing. So we're going to talk about the basic operations that you can do with a matrix. Okay, and these first ones are all pretty straightforward. Okay, so doing a row sum, okay, just means that you add up all the elements in a row. So you go across the row and add up all the numbers. Okay, similarly, a column sum is exactly the same thing. Okay. So I'm just going to flip back here for a second, but where, say, this might be useful, if I flip back to the Memorial Cup standings here, right, a quick way to check to make sure this table is accurate would be to do the column sums for wins and the column sums for losses, right? If I add up those numbers, I get 6 here and I get 6 here, and they should be the same, right? Because for every game that's played, there's a win and a loss. Okay, so I can use that to look at the logic of something with row sums and column sums. Okay, note that the row sum, so adding up these numbers going this way, wouldn't really make any sense because I'm adding up things that aren't the same units or the same ideas necessarily. Okay, so that's row and column sum. Okay, and those are internal operations. Okay, scalar multiplication means you multiply each entry in the matrix by some number. So for example, let's make a simple matrix here. And let's use 1, 2, 3, 4. Okay, so if I want to talk about 3a, right? So 3 times my matrix. Okay, all I have to do, okay, well that's 3 times this object. Okay, and all I really have to do is go through each thing and just multiply it by 3. So 3 times 1, okay, is 3. 3 times 2 is 6. 9, 12. Okay, and that's all I have to do. Okay, I can add and subtract matrices as well. Okay, but this only works if the matrices happen to have the same dimensions. Okay, so that means I can line them up and add them together. So if I kept my same matrix A from above, and let's say I have a new matrix called B, and I don't know, let's make that 5, 7, -1, and 4. Okay, if I want to do A plus B, okay, then I'm just going to take my first matrix. Okay, I'm going to add that to my second matrix. So I just line up the entries. So I have 1 plus 5 is 6, 3 plus 7 is 10, and so on. 1 and 8. Okay, so and the key thing is here is the same dimensions part, right? This only works, okay, if I can line them up in such a way that I have a matching entry for each thing, okay? Right, if matrix B, instead of being that square, had been, actually let's give it a new name. Okay, if I had some matrix C, that looks like this, okay, even though they have the same number of entries in them, I can't add them together because I don't know which one I'm supposed to match with which. Okay, so if I try to do this, okay, it doesn't work. Okay, so this is undefined. That's what I want to say. Okay, I can't do that. Okay, so before we go any further, we're going to take a moment here and look at the graphing calculators. So the red bin for that is either somewhere at the back of the classroom or it may be inside the gray cabinet right beside my teacher's desk. So take a moment right now to get those out, and then we'll resume the video after that. Okay, so hopefully you got this in front of you now, and I'm going to show you how to use the graphing calculator to do some of this for you. Okay, so turn it on. Okay, and again we'll do our clear. So that is second plus 7, 1, 2. Okay, and we're cleared. Okay, so right here above the x minus 1, there is a button that says matrix. I don't know why they couldn't be bothered to put the I in matrix there, but there it is. So we press second in matrix, and we come into this menu. Okay, to create one, you have to scroll over to edit. So we click the mouse a couple times here. So let's say I use my original matrix A up here. So enter. Okay, first I have to put in the dimensions. So this has 2 rows and 2 columns. So my matrix is 2 by 2. Okay, and I fill in my numbers 1, 3, 2, and 4. Okay. While I'm at it, let's put in matrix B. So we'll do the same process again. I'm going to go second and matrix. And I'm going to go over to edit, and I'll make a matrix B. So that's also 2 by 2. And 5, 7, -1, and 4. And just for kicks, I'll do matrix C as well here. So you can do that too at the same time. Oop, that did not work. Okay, over to edit. C. Okay. So when you're done loading in whatever matrices you want to use, okay, to get back to the main screen, you want to press the second button and then mode, because it says quit in the yellow letters there. So second, mode, I'm back on the main screen. Okay, so now if I want to use them, we just go back into that menu, okay, and you just select it from names. So I'll just take the first one there. There's my matrix A. And if I press enter right now, it just displays it on the screen, right? 1, 3, 2, 4. If I want to do 3 times A, like I had here, well, 3 times, don't even need to use that symbol, right? 3A, and there's 3 times A. Okay, if I want them to add them together, so I want matrix A plus matrix B. Where did matrix B go? Okay, add them together, done. Okay. And hopefully the calculator will not like it when I try to add together the ones that you can't add together. So if I do A plus C, error. So dim mismatch, dimension mismatched, you can't do it. Okay, clear. Okay, so question for you then. What do you think is going to happen if I do matrix A times matrix B? Okay, and don't hit enter right away here. Okay, think. What do you think is going to happen? Okay, make a little prediction first. Maybe share it with the class. Okay, and then when you're ready, go ahead and press enter and see what happens. Okay, so if we're ready to go now, okay, I have a feeling you may not have predicted this as your outcome. Okay, more than likely you probably said, well, you just multiply the numbers together, which totally makes sense based on the definition of adding and subtracting. Okay, well, unfortunately, that's not what is happening here. Okay, so the last operation we're going to cover is matrix multiplication, right? Not scalar, matrix, which is very different from the other operations. Okay, so matrix multiplication is based upon what's called row by column multiplication. Okay, to multiply a row by a column, you do the first element in the row by the first element in the column, and second in the row by second in the column, and so on. And then you have to add them all up. Okay, so this sounds a little bit weird. Okay, but we'll do an example here to show what's happening. So here's my first. I just have a simple matrix that's a single row and a single column. So the way I multiply these together, right, is I take the first element in the row, right, first in the row, and multiply it by the first element in the column. Okay, so I have a 1 times 2. Okay, then I'm going to take the second element in the row and multiply it by the second element in the column. So I have a 4 and negative 1. And finally, add the products together. So I'm going to add those two things together. Okay, so here I'm going to get 2, here I'm going to get negative 4, so that gives me negative 2. So when I multiply this row by this column, it collapses to negative 2. Okay, so try this one on your own for a sec and see what you get. Okay, so I'm not going to write it out here, but I'll talk it through. Right, I'm going to have 3 times negative 1, which is negative 3. 5 times 0, so that's 0. And 2 times negative 3 is negative 6. So negative 3 plus 0 plus negative 6 is negative 9. Okay, so that would turn into negative 9. Okay, and this last one, well, I try to start this off. I go 1 times -2, 3 times 3, and 4 times, I ran out of room here. Okay, this is undefined, kind of like before. If I can't get them to line up properly, and I can't match everything together, it doesn't work. You can't do it. So that's just for a single row and a single column. Okay, what if I had the square matrices that I had before? Okay, so you can do this, okay, for whole matrices, but you're going to be doing a series of multiplications now, okay, provided the dimensions are okay. So if A is m by n, and B is n by p, right, so, right, this is the columns of n, how many columns it has. This is the rows of B, they're the same number. Okay, and we're going to say that C is equal to A times B. That means C has to be m by p. So this many rows by this many columns. Okay, where each element is formed by multiplying the ith row of A by the jth column of B. Okay, and again, when we talk it through an example, it'll probably make a little more sense than what is saying right there. Okay, so here's the different things or steps that I like to take here. So first thing I'm going to do is list out my dimensions. Okay, this matrix has 2 rows, right? 1, 2, and 3 columns. Okay, so this dimension is 2 by 3. Okay, this matrix has 3 rows and 1 column. Okay, so this is 3 by 1. So the first step here is that those numbers, right, this here and this here have to match. Because when I go from this row, I have to be able to line it up with things in this column. Okay, so those match. Okay, next part. The resulting matrix is m by p. So that is this number here and this number here. So my new matrix I'm going to get is going to be 2 by 1. So I'm going to have 2 rows, right? 1, 2, and 1 column. Okay, how do I decide what goes in that column? Well, I start with, this is my first row, right? This is row number 1. Okay, and there's only 1 column, but this would be column number 1. So I do my row by column with this, and it goes into position 1, 1. So my first row and my first column, right, is where that answer is going to go. So now let's run it through. Okay, 1 times 1 is 1. 3 times 3 is 9. -2 plus 4 is -8. So 1 plus 9 minus 8 is 2. Okay, so my top position is 2. Okay, now I move on to the next column. This is in my my next row. This is my second row. Okay, and this is my first column. So this goes into position 2, 1, right? Second row and first column. And I just do it again. 4 times 1 is 4. -1 times 3 is -3. 0 times 4 is 0. So 4 minus 3 plus 0 is 1. And there's my answer. I have a 2 by 1 matrix by doing the rows and the columns. Okay, so for B and C, okay, I would like you to try those on your own for a moment. Okay, see if you can work it out. Okay, maybe actually do what we normally do. Go to the whiteboards, maybe grab a deck of cards if you want to randomize it or work with who you'd like today. Okay, and try those out. See if you can work them through, and then we'll put some solutions up here in a moment. Okay, so if you're back, here's how we do these. So again, first thing I'm going to note is that this matrix is 2 by 3 again. Okay, this one is 3 by 2. So my resulting matrix is going to be 2 by 2. Okay, so first row. So for my first entry, right, this position right here, right, this is first row, first column. So we're going to use first row and first column. So what do I get? I have 2 times 1, that's 0. So I get a 6 there. Okay, That totals up to 6. 2 plus 0 plus 4. Okay, now I go to my next position. Okay, my next position is over here. So I'm going to stop drawing these eventually. Okay, well there's my next position. So I'm going to use my first row and my second column, because this is first row, second column. 2 times 3 is 6, 0, and negative 1. So it's going to leave me with a 5 in that spot. Okay, for the next one, I've moved into my second row now. So I'm going to start using my second row. Okay, so second row times first column. Okay, 0, negative 5, and 0. So I get negative 5. Okay, and similarly, for my last position, it's going to be second row and second column, and I end up getting negative 2. Okay. Okay, for the last one, I flip them around. Now, with numbers, this wouldn't make any difference. Okay, but with matrices, this is definitely going to make a difference, because if I start by this amount of dimensions, this is 3 by 2, this is 2 by 3, okay, the 2's in the middle are what I need to match, so my new dimensions are 3 by 3. I'm going to get a completely different matrix here, even by just looking at the dimensions of the thing. Okay, again, I'm not going to go through every single step, but we proceed as normal. Okay, so my first spot, I do first row and first column. So 1 times 2, 3 times 0, it's going to be 2 plus 0, so that's a 2. Okay, next position is first row, second column. So first row, second column, I'm going to get a 3. And in my last spot, I'm going to get a 1. Okay, and now I proceed. So for my next one, I'm in the second row, so I'm going to use my second row. Second row times first column is negative 10. Second row times second column is negative 2. And second row times last column is negative 5. Okay. Last but not least, I use my third row. So third row times first column is 8. Times second column is negative 1. And times my last column is 4. Okay, and that's done. Okay, so again, this is a little bit different. Okay, so you definitely want to spend some time with this practicing. Okay, now that being said, yes, you can put them into the graphing calculator and make it work. Okay, however, there will be activities we're doing where we do these with variables, and then you won't be able to use the calculator. Okay, so make sure you know how to do this process by hand. All right. So practice work. Okay, there's some practice work from the textbook that you can look at. Okay, the first section involves adding and subtracting, so your basic operations. The second set of practice involves multiplication. Okay. So again, don't feel you have to do all those, but pick a few, especially for multiplication. Make sure you've got the skill down so you are ready to go. All right. Thanks for watching, and I hope to see you tomorrow.